So I wanted to start this video showing something that I think is really cool in MMMAudio that we'll get back to at the end of the video, which is I've got this struct here, and what I'm doing is I'm using feedback to make a sine wave turn into a sawtooth wave. And the way I'm doing that, so this struct is called FM because we're going to be doing FM. So in my struct, I've got a carrier, not using the modulator yet. And I've got this feedback. Feedback is a float 64. So, and I've got a mouse. So here's my oscillator, and it's called the carrier because in the minute it's going to be the carrier. But right now it's just an oscillator, and it's at 500 hertz. Let's change that to maybe 200. So it's at 200 hertz, and it's got this modulation value. So the modulation is just the mouse, and it's going between 0 and 0.3. And what it's getting is feedback, and the feedback is the oscillator. So we've got an oscillator, a sine wave. The sine wave is going into the feedback, going fed back, and then the mouse is controlling how much of that feedback goes into the modulator as phase modulation. And what happens is when it's at 0, you get a sine wave as it would normally output. And as it goes up to 0.3, it slowly turns into a sawtooth wave. So let's hear what that sounds like with 200 hertz. So on the left, it's a sine wave. And on the right, it's some kind of sawtooth wave. So if we plot that, yeah, it's a funny looking sawtooth wave. The higher the frequency goes, the more normal it looks, but it sure sounds like a sawtooth wave. So the reason why we're able to do that is because even though when you boot MMMAudio and you tell it to have a block size of 256 samples, the port audio that talks to the operating system is basically asking for MMMAudio for 256 samples. MMMAudio gives it 256 samples. But internally, MMMAudio is single sample. So it's always operating one sample at a time. So the entire audio graph gets processed sample by sample. And what that allows is for us to do some awesome stuff. So right here, what's happening is each sample gets fed back. And that is different than programming environments where you have to do special things to get a single sample of feedback. Most programming environments would feed back 256 samples at once, or the block size of samples. Here we can do one sample at a time, and we'll get back to that towards the end of this video. So let's now do this as frequency modulation. So like I said, I have a carrier and I have a modulator, and I'm going to use this mouse to control it. So I'm going to get rid of this mod right here. I'm going to get rid of this feedback for now. We'll get back to that later, so I will comment it out down here. So the modulator, it's going to be a multiply number there, but it's going to be more like 3000. And we're going to take the self.mod.next and give that a frequency. And I'm just going to make it so that we get a nice harmonic frequency modulation at first. And I'm using the mouse to control the modulation multiplier, right? So the frequency of the oscillator is at 300 hertz, but the mouse is going to go from 0 to 3000 to multiply that signal so that it changes how much it modulates the carrier. So we have the frequency here is 200, and if we add the modulator now, we should have frequency modulation. So let's save that, go over here. So there's your basic frequency modulation. If I plot that awesome modulated signal that we get. So what I want to do is I want to go over here, and rather than using the mouse to control this index of modulation, I'm going to use the mouse to control the frequency of the modulator and the frequency of the carrier. So that's two values. In my struct, I don't have a lag right now, but what I want to do is get those two values, lag them so that we don't hear the steps between the mouse locations, and then use those two values. So I'm going to make a lag, and lag, and it is going to be a 2-channel lag. So it's going to make a 2-channel lag, which is why we want both for the X and the Y of the mouse. So I'm going to say self.lag equals lag 2, and we need to initialize it. And it does need to know the world. Okay, so great. So my lag vals are going to be self.lag.next. And it needs two numbers, right? So it is a 2-channel lag, so it needs 2 channels of numbers. So we're going to give it a mfloat 2 that has self.world.mouse x, and same thing but with mouse y. So these two values are going to be put into a 2-channel float, mfloat. It's a 2-channel SIMD, and those are going to go into the next. And this output will be a 2-channel SIMD, so, or a 2-channel mfloat. So if we hover over this, it says SIMD D-type float 64.2, because an mfloat, that's exactly what that is. It's a 2-channel SIMD vector. And so we want to use these two values. I also want to scale these, and we can scale them actually at the same time because we want to scale them the same way. So I can also say lag vals equals lin exp lag vals 0. So those are getting 0 to 1. And the output is 0. Well, we'll say like 2, the low frequency, to 3000. So that's actually going to do those two in parallel. Okay, so this is a little SIMD vector, right? So here we can use lag vals at 0, and here we can use lag vals at 1. We don't want to use the mouse here anymore, so I'm just going to say 3000. We'll just keep the index the same. Great, let's hear what this sounds like. Sounds like frequency modulation. Awesome. So let's add, we've got this messenger, and I want to be able to change this index value. So I'm going to make a variable index, well, we'll call it multiplier, mod mul. That's an mfloat of 1-channel mfloat. And we'll add it down here, self.modmul equals mfloat 0. And that number we're just going to use right here. But we also want to be able to change that value. So we're going to use this messenger, and I'm going to say self.m.update and we're going to update self.modmul with a message modmul. So over here, we can send it a float. We're not going to send, I had this already there, but so we can send that float here. So now, if we run this, shouldn't really do anything, but we can change this value. So some classic FM sounds. Now, something I'm going to do here is do something that MMMAudio can do really well, which is do single sample feedback to cross modulate these two oscillators. So I've got the carrier and I've got the modulator, and what I want to do is right now I'm modulating the carrier with the modulator, right? But I can modulate the modulator with the carrier at the same time so that they're both modulating each other, and we'll get a chaotic circuit. So if I go over here and I already have this variable called FB, which stands for feedback. It's just a float, 64. And I'm initializing it. Ooh, I'm going to initialize it with 0. So it's already 0. It's 0 at the beginning. And then each time through, out gets assigned to self.feedback. When we loop back around, the next time the next is called, self.feedback holds the previous sample of the carrier. So now we're going to use that in the modulator to give it some, to modulate its frequency. Wow. And that will be self.feedback. And we can use the same modmul, right? So we could use different ones as well, but that's the feedback is going to be multiplied by the previous value of the carrier is going to be multiplied by the modmul. It's going to be added to the frequency that we are using setting with the mouse. And then that output is multiplied by the modmul and is added to the frequency of the carrier. So this should sound pretty wacky. $500 with sine waves, you get pretty nice stuff. 1,000. Yeah, so you can get all kinds of really awesome sounds. Something else we can do with MMMAudio is we can now go in and change the kind of oscillator that we're going to use. So I'm going to change this to os type. We can change these to maybe 2 triangle waves. That's kind of fun. See what that does. Sounds pretty awesome. And we can even go maybe do one of these as a band limited saw. Start getting some really chaotic stuff. You can hear over here, you start getting some aliasing, and we can deal with that by changing the kind of interpolation we use and into Sinc interpolation, and maybe adding some oversampling. So since we're doing cross feedback, we want to maybe do this on both oscillators. So if we're still one oscillator, but we're going to do the interp. And we're going to use Sinc interpolation and maybe 2 times oversampling. With Sinc interpolation, you really don't need more than that. So as you can tell, I can play with that all day. So yeah, this is super fun. Cross feedback modulation with MMMAudio using Sinc interpolating oscillators, and you get a nice clean signal, but it still gets all the noisy, nasty stuff that you want. So I wanted to show kind of an advanced, I guess, or show how you can take this to an extreme. So this is called FM4. You could call it whatever you want. It's just a name. And we have 4 oscillators, and these 4 oscillators are all going to cross modulate each other. And each one has a frequency, and then each one has a list of modulators, which is just 2 values. So each of these oscillators is going to be modulated by 2 other oscillators. So we, of course, have a messenger and feedback, which is a list now. So there's the 4 values, OS0, OS1, OS2, OS3, all need to feed back so that they can be used elsewhere in the circuit. So declaring the variables down here, we're using Sinc interpolation for all of these. Each one has 2 value multiplier. Feedback is 4 values. And this one uses something, it's a variable wavetable. So we can actually move between wavetables. So we're going to use a wavetable that has sine wave, triangle wave, sawtooth wave, square wave. The way we do that is instead of calling next, we call next underscore VWT underscore variable wavetable. And that has an additional argument, which is a value between 0 and 1 that moves us between the 4 different oscillator types. So for each oscillator, we need to calculate the amount of modulation. So this FM0 value is calculating the amount of modulation for the first oscillator. And so it's grabbing the feedback, which is down here. Feedback is the 4 oscillators. So it's grabbing the second oscillator, multiplying it times its multiplier. Grabbing the second oscillator, multiplying it times its multiplier. Then that is the frequency modulation. Here's the frequency. So the second one is grabbing the first oscillator and then the feedback of the last oscillator and multiplying it by those two numbers. The next one is grabbing the second oscillator and grabbing the feedback of the last oscillator. And the final one is grabbing the first oscillator and grabbing the feedback of, and just grabbing the second oscillator. So each of these, all these 4 oscillators are modulating each other, and we get some wacky mayhem. I'm also using a GUI here to control it. Obviously, way too many variables for a mouse. So there's the GUI, and also it's a pain in the butt to set all these values, so I'm just going to randomize it. So obviously that's something I could play with all day. And some pretty awesome sounds that are really possible because of the single sample feedback and the ability to then use the feedback signal as a modulator.